We are now going to begin building the manager script, which will coordinate the entire simulation. We will first create an empty game object so we can attach the simulation manager script to our scene. We will also name it Simulation Manager. Next, we'll create a scripts folder in our assets folder, then create the Simulation Manager script inside of it. Finally, we'll attach the script to our Simulation Manager game object. Now, let's open the script in our editor to begin coding. First, we'll clear out some of the template code it provided us. Then we'll include the Unity callback method awake, which we'll use to set up the manager. We are going to treat this Simulation Manager as a singleton, which means that only one instance of the script can be active in our scene. We will create a private method called enforceSingleInstance to do this. We need to keep a static reference to a Simulation Manager instance in order to control whether there's only one of them in the scene. We will define it as a C# auto property with a private setter. This means that other scripts will be able to get this instance through the class name, but only this script will be able to set the instance. Now, let's call the enforceSingleInstance method in awake, then we'll define the body of the method. We first need to check whether the instance already exists when this script awakes in the scene. We want to destroy any instance other than the main static reference we are going to keep track of. We do this by checking to see if the instance property is not null, but we also want to make sure before destroying it that it is not our current instance, because that is the only one we want to keep. If the instance property is null, which will be true in the else clause, then we will simply set the instance to this script. This will ensure that no other instances of Simulation Manager are active in the scene except this current one. This completes the basic setup for our Simulation Manager. We are now going to create a tick event, which will serve as the update for our simulation. We want our simulation to update on its own schedule that is separate from the Unity frame updates. There are a number of reasons for this, but the primary motivation is to separate our simulation logic from the rendering. We want to be able to run our simulation without necessarily updating the rendering at the same time. This is often referred to as the model-view distinction. In this case, our simulation will be the model, and the Unity rendering will be our view. The first thing we'll do is create a new folder called Components. This will help separate out the Unity components from the scripts that are going to be associated with the simulation. We will also create a folder called Info, which will store scripts that hold useful constants and information that need to be accessed by multiple scripts. Let's create our first info script to store a constant for our tick event. We'll call this Simulation Info. These info scripts will be defined as static classes with static variables holding the relevant information. So we can begin by clearing out all of the Unity callbacks and removing the monobehavior base class. We will define one static float variable called tick duration. This will be the amount of time in seconds between each of our tick events. Let's also begin including all of our scripts in a root namespace for our project. We will use MMH as the namespace. This stands for the name of the project, Moon Mist Hollow. Let's also take a moment to include our Simulation Manager script in this same namespace. Now, let's begin including some instance variables that we will need to manage the firing of the tick event in the Simulation Manager. We will need one variable to count the total number of ticks that have been fired, and we will need another variable to keep track of how much time has elapsed since the last tick event. We will initialize both of these variables to 0 in the awake method. Let's move to the update method so that we can begin tracking when to fire the tick event. Each Unity frame update, we will add the delta time to our tick timer. This is a built-in Unity variable that keeps track of the amount of time that has passed since the last call to the update method. We then want to check whether the tick timer has reached the tick duration we set in the simulation info script. In Visual Studio, you can hold Control, then click on the class name to jump to the file where the class is defined. We have defined each tick to last 0.2 seconds, or 1/5 of a second. Once we reach this limit, we can then increase our tick counter by 1, and we can reduce our tick timer by the tick duration. This resets the timer without losing any extra time that has passed beyond the time limit. If we just set the tick timer back to 0, then our next tick event might be a little too long. The first step is to define an event handler reference that will allow us to fire the event. We will make this reference static so that other classes can subscribe without needing to access the instance of our simulation manager. We will also use the event keyword when defining this event because it provides some built-in functionality that makes working with events safer. We need to use the system namespace to get access to the event handler class. The next thing we need is an event args class that allows us to define custom arguments that we can pass to the subscribers when the event is fired. We will create a new folder to store these event args classes. Inside this new folder, let's create a script called onTickArgs, then open it in our editor. Let's add our script into the MMH root namespace, then we will define our class with the event args base class, which also comes from the system namespace. This class will have one public variable that will hold a reference to the number of ticks that have occurred. Now, we can return to the simulation manager and include this new class as the template argument to our event handler. This completes the definition of our event handler. We want to check to make sure the handler has at least one subscriber before firing the event. There is a special operator called the null conditional operator that can be used to do this easily. By including a question mark after the event handler, it will only call the invoke method if there are active subscribers. Now that we know our onTickInvoke method is being fired safely, we can supply the arguments it needs. The first argument is always going to be a reference to the object that is firing the event. We use this to reference the current object. The second argument is going to be an instance of our onTickEventArgs class. We set the tick variable in the event args to equal the value of our simulation manager's tick variable. This completes the setup for our onTick event. Next, we'll move on to defining our first simulation script. This will be the system that manages the world map.